All right, so f of c is the absolute min if f at c is less than or equal to f of x for all x. Now, in this form, it's pretty easy to see what's going on, but when they're in a multiple choice format in the AP, this can be kind of confusing. I'll show you in a little minute. Let's move on. Straightforward notes for a while, then we'll practice on the back. All right, no, not everything has an absolute extreme, or it has an absolute maximum point. You can see the parabola, for example, it has no absolute max. It goes forever up, and because of that, it doesn't have an absolute max, although it does have an absolute min. It doesn't have a maximum value, but it does have a min. Endpoints, then, tend to help you get extrema, but not guarantee it. For example, having one endpoint guarantees you, in this case, an absolute min, but no max. A line, pretty basic shape of law, has no absolute extreme at all. Endpoints, it kind of depends on if it's a closed interval and included or not. If it's a open interval, then does that have an absolute min, do you reckon? Or max, excuse me, absolute max. No. Okay, then a goofball, if I were to throw this up to a pre-algebra student, they would say, yeah, the absolute max is the point right before that dot. Well, what the heck does that mean, right before that dot? That's ridiculous. So in that problem, there is no absolute max, because no matter what point you chose, you could always choose a point halfway between those forevermore. And so it has no absolute max, although it does have an absolute min. And then obviously asymptotes wreak havoc on absolute extrema because of the infinite behavior. Now then, when are you guaranteed to have an absolute extrema? This is called the extreme value theorem. It's actually a pretty big idea in calculus. It's probably one of 7 or 8 huge theorems in Calc 1 that you learn. If a function is continuous, if two things happen. First of all, if the function is continuous, so as not to jeopardize the asymptote idea, on a closed interval, then there must be an absolute min and an absolute max. It must have a very lowest point and an absolute maximum or greatest point. You will also be asked questions on this. When does this have to have an absolute min or max? That's a tough question. We'll practice that. Would you now consider this picture here? This is a place where we're going to look. It's going to govern where we're looking. You can see that A is special because it has an endpoint. B is special because the derivative is 0, and therefore it's a critical number. C is obviously a good candidate for max because it's higher than the others. And what's going on at C? F prime is undefined or does not exist, which makes it a critical number. Okay? D is there to prove a point. It's special because the derivative is 0, but you can see that it's not panning out as an extrema. Remember, derivative equals 0 is a place to look, but it's not guaranteed to yield an extrema. It's just a place where we might be turning directions, but it doesn't have to turn directions. E is also special, especially for non-functions. If you think circles, you can actually have absolute leftmost points or absolute rightmost points at a place where the derivative does not exist because it's a critical number from vertical tangent. Vertical tangent. So that helps find extremas on non-functions. F, I don't know what F is doing for me. It's telling no new information. It's the derivative of 0. Obviously, that's a critical number, but I don't know why I put F in there. It's not new information. And then G is special because it's an endpoint. You can see then that point Z, which is right here, has absolutely nothing going on for it. It is not special in any way. It is void. It is neither an endpoint nor a critical number, and therefore it has no chance at being an absolute max or a min. In fact, what's called Fermat's theorem, a minimum and maximum can only be at an endpoint or a critical number. When you go to find an absolute extrema, you really only have to look one of two places where there's something special going on. That then is what the problems look like. So turn to the back, that's where you're going to see the problems. First, the book kind of problem, and then a couple AP problems, and we'll see how this goes. The book problems are pretty straightforward here. If it says find the absolute min and max of f of x on a closed interval, then you're just finding on this cube what's the absolute greatest point. Now you can see that they're closing it off, and it'll kind of depend on where they close it off. If they close it off or end it here and here, then I'm probably not going to get either critical number in the mix as an interesting point. If they close it here, then maybe I'll get that critical number, but not that one. And then maybe the interval will end here and there, in which case I'll have a couple or four interesting points. Right? So I don't really know what the interval is doing to the curve, and I don't need to graph it. It's going to be a case more like you gather the candidates and figure out the f value at each of these candidates, and that'll tell you what the absolute maximum is. Excuse me. So, step 0. I don't know if Ms. Kennedy asked you to do this, but I was taught to do this. I think it's good math, and that is basically to state Fermat's theorem. The absolute extrema must be at an endpoint or a critical number. Feel free to abbreviate it. To me, that's like the thesis of the problem. This is what's going on. I'm looking for absolute extrema, and this is where I'm going to look. The why of it is the theorem itself. You do not have to cite Fermat's theorem. All right. You now gather the candidates. The endpoints are obviously given, -2 and 0. The critical numbers, you have to do a little more work for, and you need to be clear about where they come from. The critical numbers are where the derivative is 0 or dne in the domain. So I need to show the person what I'm doing here. The derivative, what is the derivative? 3x squared minus 3. I want to know whether this is 0 or dne. I think that you will see that this happens at -1 and 1. However, as far as in the domain, they are closing it off at 0. They're stopping at 0. And so it seems like I'm getting two flat spots, -1 and 1, but they're only including the one at the left, or the interior at -1. Okay? So you could communicate x equals 1 is not in the domain. But now we're ready to gather the evidence. Okay. Now, I know that just looking at my picture, one of these two might be the absolute min, but I don't really know. I didn't draw that to scale. For all I know, this point is below that point. I don't know which of these is lower. I'm just drawing kind of rough and scaling this. To actually find what's the absolute min, I need to find now f at each of those to decide, oh yeah, that's where the y value is the lowest. After you've gathered the candidates, you now find f at each of the candidates. I want to know what is the y value at -2. At -2, I get something like -8 plus 6 plus 1, which is -1. At 0, the y value is +1. I kind of know by picture, but I'm going to gather the evidence anyway. I also want to know what is the y value at -1. F at -1 is -1 plus 3 plus 1, or 3. Now I know, from what we just talked about, the only place the absolute min and max can be as an endpoint or a critical number. So really, these are the only 3 candidates for absolute min and max. It can't be any others. So now I just need to decide, all right, what is the absolute min value of the function? The absolute min, or the minimum value of f, is Now here's where another common mistake is made. I had a lot of people that say the absolute minimum value of f is -2. True or false? False. Why? Yeah, that's the x at which the minimum occurs. The actual minimum value of the function is a y value, and the lowest y value is -1. Now, that really is the minimum. Some people on the AP rubrics, you'll often say, because this is the least of the candidates, it's the least of the candidates. I know Miss Cannon might do something like because -1 is less than 1, which is less than 3, and that's fine too. Any of that is gravy to me. Obviously, the very minimum is to say this is the minimum value of f to answer the question. What is the maximum value of f? It's 3. Okay. Now, be careful to answer the question. Sometimes it'll say, find the x at which the minimum occurs, in which case you get the x. But sometimes it'll say, what is the minimum value of the function, and then obviously you get the y value. All right? So read the question carefully. That one's pretty much like you'll see in the book. Gather the candidates, show where the derivative is 0, find f at the values, and then make the conclusion based on the greatest and least y values you see. An AP style might be another couple layers to this. You may, well, let's hold off on calculator. I don't know you'll need a calculator for this here. Yes?
Do you require that table format?
No. If you did something like, so I require absolutely that you show that is graded for an AP. The table, I don't care. If you just had a list, f at -1, f at 0, f at 2, that's fine. So no, to answer your question, I don't. Okay, it's a nice organizational tool, but it's not required, nor is it universal. Right, people, so this we've been playing around with a little, and you can see that there is an extreme value theorem or an absolute extreme problem to this. Say people enter at a rate of 2t plus 3 people an hour, where t is time in hours since the store opened at 10 a.m. People leave at a rate of 6t minus t squared. There are, same thing, people per hour. There are 2 people in the store at 10 a.m. What is the maximum number of people in the store from 10 to 4 p.m.? If you were to underline this, if I were reading this question, when I read this, I would say, what is, and I would underline the. That is the key word in the whole problem, that little article. It implies absolute. All right? That's what tells me I need to find what is the absolute greatest possible outcome of number of people on this. There's so many things to keep track of. Okay, it's like trying to herd 8 cats at a time because there are 8 little things going on or something like this. First thing is, I would say the big idea is the absolute max must be at an endpoint or a critical number. Now, normally I would say endpoints are a no-brainer, but even in this problem, endpoints aren't a no-brainer. Are the endpoints 10 and 4? Let's read carefully. Where t is time in hours since the store opened at 10 a.m. So, are the endpoints 10 and 4? They are not. They're 0 and 6, okay? The endpoints are time equals 0 and 6. Where time equals 0 corresponds to the opening, 10 a.m., and time equals 6 corresponds to the 4 p.m. All right? So read carefully. Or critical number. Now, critical number is also loaded. That's another cat we have to herd here. Critical numbers, normally I'd say where the derivative is 0, but there's not really a function here, and there's more going on here. So I'm going to do a little more universal, and instead of saying the derivative is 0, I'm going to say where the rate of change equals 0 or does not exist. If I were to talk about the rate of change in the number of people, let's say I don't even have an expression for the number of people at any point. Let's let n of t equal the number of people. If I want to find a max of number of people, then I want to know where n prime is 0 or does not exist. Well, what is n prime? The change in the number of people with respect to time. What goes into the rate at which the number of people is changing? Yeah, enter and leave. And is it the sum of the two, the product of the two, the difference between the two? It's the difference because they're saying L represents is not negative on its own. L is just how many people leave. Now I want to take how many people leave away, so it's E of t minus L of t. Okay? I want to know where this is 0 or does not exist. All right. So if I'm trying to find the critical numbers, and the critical numbers where the rate of change is 0 or doesn't exist, then I need to figure out where 2t plus 3 minus 6t minus t squared is 0 or does not exist. In essence, then, I'm really finding where they're equal. Now, if I'm finding where they're equal, that makes sense because before they're equal, one must be growing more than the other. And they must be entering more than they're leaving. And after, they must be switching off. So it makes sense to find where they're equal because before and after that point, it must be changing. So if I were to factor this, to distribute this, I get a t squared minus 4t plus 3 equals 0 or d and e. We can factor that. Then we get something like 1 and 3. All right. So the store opens at 10 a.m. or times 0. It's either more people are coming in and leaving or vice versa up to 1. And then at 1, the entering and leaving rate is the same, and afterwards it's different. So it's growing and shrinking and growing and shrinking. We need to figure out when it's at its greatest. That's where we now find the amount. We gathered the candidates. Now we need to find the amount at each candidate times 0, 6, 1, and 3. Now again, just as this, we need to use the table. I don't care if you use the table or you just organize it. But do please label it. Don't just throw calculations at me with no label. So for example, amount at time 0, what is it? That's 2. Now that's given, there's no calculus to that. The amount at time 1, that's where things start to get a little more complicated. Fundamental theorem stuff. We have rates at which people enter and leave. If we want amounts, we need to take a rate times an amount of time and add all the calculations. So fundamental theorem. How would I find how many at time 1? Yes?
I have a question.
Please do.
Do we have to number everything?
No, just no purposes.
Do we have to say find amount?
No.
So I can just say 0.
Yep. Okay. All right. The amount of time 1. I would need how many started with and how much the amount changed up to that time. So what's the number we started with? That's some reference point. We add 2, and then we add on to that how much it changed. How do I add how much it changes by giving a rate of change? We integrate from 0 to 1 and how much it entered, which is positive, how much it leaves. Please feel free to use their names. Do not write the functions. That's a time waster. In your calculator or by hand, whichever you prefer, you'll find that if you just enter this once, you can often go back and just keep changing the values after that. So at time 1, I have roughly 3.333 people or 3 people in the store. Okay? So over that hour, some people came in and some people left, but as a net rate of change, one more person came in than left, right? What about at time 3? Show the setup. and then use your calculator to calculate. At time 3, if you want to put this in your calculator, great. If you don't, that's fine. At time 3, I have exactly 2 people. So it must have shrunk, or the leave rate was greater over that 1 to 3 time frame. And then at time 6, the end point. The change from 0 to 6. On top of how many there people were there how many people there were to start with is 20. All right. Now I established the only places the absolute max could happen is at these 4. Of those 4, the greatest number of people is 20. So now let's answer the question. Does the question say when is the number of people at a maximum, or what is the maximum number of people? What is? So I would conclude that the max number of people in the store is 20 on the interval. Okay? Yes?
Does A of t equal t?
Oh boy, I identified 2 totally different functions. Yeah, that would have cost me a point on the AP test. Good point. Oops. Now, because this class is heavy on people like Ms. Cannon last year, the way I did this, I showed where every one of my values came from. You can avoid all that writing, which on the AP test might save you a little, if you identified the number function as a dummy variable kind of function like this. If one place in your work you said, this will be how I find all amounts, generally, then you would only have to say, n at 0 is this, n at 1 is 3, n at 2 is, or n at 3 rather is this, and n at 6 is this. If you did a general function at all, then you're covered. Okay. However, if you only did, students want to say, well, I showed you how I found n at 1, but then you didn't find that. That would cost you on the AP test because you didn't show. You just showed me how you find n at 1, not how you find n at 3. Okay. So if you want to save yourself some writing, then create a dummy variable function that shows, hey, this is how I'm finding it in the amount, and then you can avoid the writing. Okay? Questions? All right, we'll practice this. Maybe if I put the front sheet tomorrow, we'll practice this. There are a ton of AP problems on this. Last kind of idea. Fundamental theorem or area accumulation with absolute extrema. Say you're given the graph of f of x, and I give you g as an area accumulation function. Find where the minimum value of g occurs. All right, so let's start with the big idea. Absolute min occurs. Absolute min as an endpoint or a critical number. Endpoints being x equal -3 and 3. Thank you. And or a critical number. The critical numbers require a little more than just vision. I need to get into critical numbers. Critical numbers by definition are where the derivative of what you're looking for, which is g prime equals 0 or d and e. We talked, however, about if you are not given g prime, you're given f, then you're making an inference, and so you need to communicate that inference. So what's the connection of g prime to f? G prime, which equals, if g is the antiderivative of f, then g prime is f. Okay, if I took the derivative of both sides, it'd be the derivative of the antiderivative. G prime is f. So to find critical numbers, I need to know where f is 0. That is at, it looks like 3 halves, yes? -3 also happens, but that's already in my endpoint list, so I'm not going to do that. Are you with me? Okay, so I gathered my candidates and I showed where my critical numbers come from. The second is then to find G at each value. Again, you don't have to write that. You could just go straight to G at -3. It doesn't matter what order you find them. I just typically go left to right, but it's up to you. G at -3 would be to take the G function, put a -3 in for x, which would put it there, and right away that bothers me. I don't like limits of integration that go greater to lesser, so let's switch this. When I switch this to -3 to 0, what must I do? Negate, okay? Now, I'm all set up. Now I find my integral values by area. When I find this integral value, I look at the area here. And the first thing I decide is that area above the curve or below the curve? Are the y values above or below? And that most definitely is above, so it's a positive area. Geometrically, I can find that area by a quarter area. And so what is G at -3 at the end of the day? -1/4 pi times 9? Yes? Okay. Now that actually makes a good deal of sense to me. It grew up to this point, so if I go backwards, then I must have lost area, so it's negative. G at 3/2. Again, I'm just going left to right amongst my candidates. -3, 3/2, and 0. G at -3/2 is 0 to 3/2. That doesn't require switching of the limits of integration. It's already going lesser to greater. In terms of area, it's a positive area because it's above the axis, the x-axis, and it's a triangle. What's the base of that triangle? 3/2. What's the height? 3 divided by 2. And so G at 3/2 is 9/4. Last candidate is G at -3. No, +3, excuse me. G at +3. What is the area from G at from 0 to 3? Nada. It is indeed a positive triangle and a, if you like, you don't have to show this, but it's a positive triangle and a negative triangle. Altogether, they're the same area, and so you get a net 0. Now I can conclude. Identified our candidates. We found the y values or g values at each candidate. Now my conclusion. Make sure you answer the question. What's your answer? Should we say -9 pi over 4? The x. And so what's our answer? -3. Okay. The minimum value of G occurs at -3. At x equal -3. Okay. They didn't ask in this case what is the minimum value. They just said where is the minimum value. All right. Let's check for understanding here. Shall we? Two false problems. Generally are about 50% success the first time I put them on a test. Let's see if we can get above that. Is it true or false that a function can only have an absolute min-max if it's continuous on a closed interval?
No.
No. Okay. Some say yes, some say no. Give me a counterexample.
Well, you can have an absolute. You can have one or the other if it's not.
Yeah. I'll give you a counterexample here. Does that have, oh, you mean and. Is the
That's
problem
not
with your
close.
and? Oh. I also, no, thinking I can definitely make a function that has an absolute minimum. What is, let's say this. I can make that. Does that have an absolute minimum?
Yes.
Is it continuous? But is it on a closed interval?
No.
No. So, must, can it only have a max and min when it has those conditions? I guess the problem is that you're thinking that's can be switched, and it can't. It's not necessarily true. The opposite. If it's continuous on a closed interval, then it must have an absolute min and max, but it can't be necessarily switched. If it has an absolute min and max, then it must be. That is not true. Okay, is it true that f at c is, if f at c is greater than or equal to f of x, let's add in here for all x, then f at c is the absolute max on the interval. Is that true or false? If the y value at c is greater than or equal to all other y values, then that is the absolute max. It's true. That's the definition of absolute max. If f at c is the minimum value of the function, it's implied, when it says the, it's implied absolute min. X equals c must be at an endpoint or a critical number. If I know that the min is at c, then must that be an endpoint or a critical number? Yeah, that's Fermat's theorem. If f has no critical points, it has no max and min value. That's false. Okay, for example, just boom, there. That has no critical points, and yet it has an absolute min and max.
All right. The way you explained the first one got weird. I still think it should be true.
You can only have.
That's false. Well, okay, let's say.
And
So it's the and that's causing you?
it's the only and the and.
Oh, only is a strong word. You're right. A function can only have an absolute max and min if it's continuous on a closed interval.
So is the example that you gave, like, does that mean 80?
It does. That is a counterexample. It is not continuous on a closed interval. Again, it does have an absolute max.
Okay.
So that's a counterexample I give you. Yes.
Okay, and then I have another question.
Sure, hit me.
If you have, like, an x function?
Yes. With no
Would
endpoint.
those be relative?
They are relative.
Okay.
Um,
Alright.
You bet. If you think x to the fourth, by the way, you have to, that's an example of the find it out or why you compare values. It has two possible mins, but we need to decide which. And so you'd have to compare the two candidates. All right, good deal. Questions on, I want to get 60 extra practice area of X fun sheet done. So, towards that end, the area of X fun sheet, the key is online, so you can check your answers to there. I would encourage you to use it judiciously and not just mindlessly copy. And the 60 replacement answers are as follows. 9 actually is not a replacement, but as somebody just shouted out 9 right away before I even started hitting replacement, so I went over 9. So don't worry about 9. 9 is in the book. But in terms of replacements, 13 on set 60 was you have a rate at which people enter and a rate at which people leave, and you are supposed to, first of all, graph and talk about when the amount of people is growing and leaving. Are we clear where we're at? Sorry. Should I give you a second?
That's like there's like 213.
Is that why it starts?
There's an enter and leave at the bottom of the first page, but then there's a 13 at the top.
Oh, I'm referring to the replacement. I'm sorry. That's right.
I think we were
Yeah, we already went over that.
Oh, we did?
Yeah, we did go over the last one.
Oh, excellent. Perfect. All right, so we did the period thing?
Yep.
Okay, cool. All right, so these are my answers to the last one. In part A, they asked for 3 things. G at 0, which is the area under the F curve, is 2. In all cases, make the connection to F. Please make sure you establish the connection to F. G prime at 0 is equivalent to F at 0, which is reading the graph. That was 2. G double at 0 is equivalent to the derivative of F at 0, and that's the slope of the graph at 0. That was 1. Okay. B, that's where's G concave up. Again, make the connection to F. G is, I started with the big idea of calculus. Something's concave up if its second derivative is positive. So that's what I'm starting with. G is concave up if G double, which is equivalent to F prime, is positive. That occurs where the slope of the F graph, I'm actually making an inference. I didn't show enough work. Slope of F is positive, and that's on negative 2 to 1 and 7 to 3. Yes?
For that one, why are the endpoints exclusive and not inclusive?
They said open interval in the question, but they would, on terms of the interior endpoints, you could include them or not include them. That's kind of a bit of argument between teachers. In the AP test, they grade for open or closed. Okay. It's really, do you consider it increasing, decreasing, or neither at the endpoint? And there's no agreement on that. Good question. C. Where is G increasing? Again, connected to F. G is increasing if G prime, which is equal to F, is positive. That doesn't really require an inference. That's just looking at the graph. The graph is positive on those intervals. Again, open or closed intervals are fine. Okay. Questions on either set 60 or the fun sheets. Just because my key is online doesn't mean it's all clear. So let me know if you have questions on 60 and fun sheet. 14 on 60, yes.
Number 1.
1. Okay. Ben. All right. 14 and 1, 60.
And do you mind if we check the...
No, not at all. Thank you for asking. I can also put it up here after we get through the 60 questions. We can look through it. 14 is the explicit, which is to say, never mind, I worked, okay. I solved for inverse. Okay, so here we go. Write the explicit inverse equation. So if you do an inverse, the minute you do, you're switching x and y. This is the implicit form. Implicit is implied within, y is not solved. If they'd asked for implicit, yeah. So yeah, y equals r.
I just why.
Actually, I would prefer that, actually.
You would? Okay.
Yes.
Okay, but then the answer they have is not that.
What did they have?
They had y equals y.
Yeah, I would prefer y inverse, or if you like, to be safe, maybe f of x, let f of x equal that, and then that. But you're fine. Okay. Any other questions on 60 before I move on to fun sheet? Okay, cool. Do-do-do. Do-do-do. Okay. There was one of these where I forgot to name the graph. I apologize. Okay. So the idea, pay attention to the negatives, and the idea being to make or force a positive area. This would have been a negative area, so you need to take some steps to make it positive. You actually could do that a number of different ways. You could slap a negative out front. You could negate G. You could say 0 minus G because that's upper minus lower. You could even switch the limits from B to A. That would make it negative. You'd see all those possibilities in a multiple choice, all right? But you definitely need to take some steps to make it positive somehow. Same goes with all these. And the region from A to B would be positive left alone, so you leave it alone. But the region from B to C is below the axis, so it needs to be negated in order to make it positive area. If you want this region, then you really need to take the difference between the upper y value and the lower value, this is 2, take away f, or h, gives you that height. Again, total, take away the lower part, gives you the part you want. So 2 minus h is the heights, dx is the bases of the rectangles. In region 4, you're again trying to force positive areas. If you just take upper minus lower, you'll find that that is a theme throughout all these. If you take upper minus lower, you'll get positive heights to your rectangles. Along with a positive dx, you'll get a positive area. So in every case, you'll see me doing upper minus lower. In this region, the upper is 2, the lower is the curve. So it's 2 minus f for the first region, and then the upper is f, and the lower is 2, so it's f minus 2 for the second region. Not sure what I was, artificial endpoints, sorry. Sometimes instead of having endpoints created by intersections, they just give an artificial endpoint like an A or a B, x equals A, x equals B, in which case you use them, that's easy.
For that one, why don't you need the absolute value signs?
Good question. So you would get the same answer if you had absolute value, but why do you need absolute value?
Well, if you're
Because
trying
you
to
have
find the total area and part of it's below the x-axis.
So actually, let me say this. Did you do this? Or did you do this?
The second
Okay, that's okay. This would be wrong. All right. It's actually not necessary because, imagine, I'll say it this way. If I asked you, how far is it from -2 to 3, then isn't it enough to just say the upper minus the lower, the distance is 5, and it makes it positive? So the absolute value, although true, is unnecessary. And if you're integrating by hand, complicates things.
Okay.
So, yeah, you bet. I'm glad you asked. Okay? If you do upper minus lower, it should be all good. Now, because you threw that absolute value idea, that's actually a great point here. What if I wanted to express this as one integral? How could that be done with absolute value? See this? Okay, so this, I wish I would have written this, a problem like this. This one, part B. Imagine if I had done this just straight up from A to C of f minus g. Forget the b. In every case, I'm taking the difference between the two y values, absolute value of f. This is what I meant to say. There was a mistake. Now, if you have a calculator, that kind of thing can be done because your calculator handles the absolute value. And basically, it's making this curve up here where you're getting positive y values, and you'll get positive area that way. So this is also an option. Unfortunately, though, integrating that by hand is not going to happen, and so that's why I'm practicing with two. Are you with me? Okay. So again, this one you could write as 1 with absolute value, and all these you could write as 1 with absolute value, with the exception of this one. This one, no matter what, absolute value or not, you'd have to use 2. So that I'm looking at two different upper minus lower situations, so that's why you see two integrals. This one I gave you an artificial endpoint, but then an intersection point, so that's the idea on that. This is a bit of a gotcha here. If I were to draw rectangles here, in this first section, I'm going up to g of x, so I could integrate g of x. But the minute you get over here past a, now your integral or your y values are f of x. If that's the case, if you have two different upper curves, then you need two integrals at least, and that's calculator or not, you would need to do. Okay? All right. Did you get B, C, C, B on the front? B, C, C, B. What'd you get?
Can you hold on number 5 for a second just so I can look at it?
Oh, sure. Oh, 5, there it is, my bad. And I will zoom out a little so you can see it down. The idea there is I'm giving you one intersection to close off the region on the left, and I'm giving you an artificial endpoint on the right.
Welcome back, everybody. Please rise for the Pledge of Allegiance. Ready? Begin. I pledge allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
All students
Let me know if you want me to move down.
Thanksgiving break. The NROTC scholarship presentation has been rescheduled for tomorrow during 7 hours. The Navy and Marines will present their NROTC scholarship worth $200,000. Don't miss out on this opportunity if you have any interest in the military.
I know.